Okay, good afternoon, everybody. This afternoon we're talking about integrating security into DevOps, and your presenters are from Sonatype. My name is Mike Donovan. I'm the technical director for our federal team, and Curtis Yanko is joining me, is in charge of our alliances and channels. So those who were in the presentation by USCIS on the main stage earlier today, they had the panel discussion, DevSec and Ops. That aligns very much with what we're doing at Sonatype these days. And so getting security into Ops, a lot of what we'll see in what we promote with Sonatype traces back to auto manufacturing and W. Edwards Deming. When you look back to post-World War II, Deming helped Toyota and a number of other companies really accelerate and improve the manufacturing processes for automobiles in Japan. From 1960-ish or so to about 82, Detroit lost more than 25% of its market share to Japan because they weren't keeping up with the new technologies out there. And one of the things Deming quoted, and Detroit eventually caught on to, you can't inspect quality into the product. You can't build the car, then send it to QA and have them inspect the quality in. And when you get into developing software, manufacturing software, it's the same story. You can't inspect quality in, you can't inspect security in at the end of the process. But one of the things that we see today, development teams don't just write software code from scratch anymore. They manufacture it. Billions of components from open source communities, and those represent 80 to 90% of a modern application. Only 10 to 20% is original custom code. And then these open source components that they're using are coming from all sorts of public sources like Docker Hub, the central repository for Java, Ruby Gems, NPM for JavaScript, etc. And they form, if you go back to the manufacturing comparison, they form your software supply chain. Suppliers, the open source projects that you're pulling components in from. A local repository where you store them, the warehouses. And then you pull them from the warehouse to use in the manufacturing, which is your software development teams. And then the finished goods are the software applications that you're delivering. Those components that we're bringing in, how big of a problem is it, or a topic is it? When we look at the open source community, thousands of new projects every day, 10,000 new versions, typical project releases 14 or more times a year. So you've got massive amounts of components out there that people are using, and just looking across some of those different infrastructures. The central repository, which is where most of the world's Java comes from, 17 million 2 years ago, 31, and then 52 last year. So billion. So it's extremely high volumes of components. NPM, JavaScript components, 59 billion last year. Python, ooh, boy, that's washed out.
Yeah, that's what I was saying.
57.4 million downloads from Python. And Docker Hub was 1 million 3 years ago, 1 billion a year later, 6 billion last year. They're predicting 12 billion this year, and I wouldn't be surprised if it's higher than that. So vast amounts of this stuff that people are bringing in and using in their applications. The challenge is not all of these are created equal. Some parts are good, some parts are bad, and even the good ones are going to go bad over time. If you download a component that's good today, 6 months or a year from now, somebody's found a new vulnerability in it, and you're still using it. Some of the statistics, Sonatype publishes a state of the software supply chain report every year that identifies a lot of statistics about what's happening in the open source community and all of these components that people are bringing in. Current numbers, 6% of current downloads are vulnerable, so it's already bad when somebody downloads it. Things stored in local repositories, similar percentage of the things that people have stored are bad. And when we look at the applications in production, It's even a little higher. Close to 7% of the components that are deployed and in use are bad. So people often download these components but have no knowledge of what's in them. Average, over 7,500 organizations surveyed, averaged 125,000 open source components downloaded per year. Many of the bigger companies in that survey were 250 to 500,000 components. So that's a lot of stuff to keep track of if, when you're downloading them, that percentage already is being downloaded with known security vulnerabilities. So how do we get the productivity gains of using open source components without increasing all the risks of these things that are out there? Going back to the manufacturing reference, principles from Deming, first is use fewer and better suppliers. So think about the car manufacturing. You don't want to use a different manufacturer for the tires on this car and for the tires on that car and for the tires on that car. Choose the better supplier and then use only the highest quality component from those suppliers. When I mentioned, if I compare this back to software, the average project releases 14 times a year. So even if it's the best project out there, there's probably only 2 or 3 revisions of that project that are the best components you should be using. The others are outdated. Maybe a problem was found in them, which is why a new version was released. So choose a good supplier, but then make sure you're using the best that that supplier has to offer. And finally, know where you used it. Think about a Takata airbag. Back to the car example. They know which models to recall every time another flavor of Takata is discovered to be bad. They say, oh, that's this year's model of cars and that year's model of cars. They track where it is. So when you are notified that there's a problem, you know where to go clean it up. I've heard several times mentioned earlier today, Struts 2. When that was reported in March, I was talking to one government contractor who said they had to do a complete stop work on development and put all hands on deck just to search through all of their applications to find it so that they could fix the problem, because they knew they used it, but they had no idea where it was. I repeat that story to other federal agencies that I'm talking to, and I'll get comments like, well, I can't confirm or deny, but we might have had to do the same thing ourselves. So they won't flat out admit it, but they're more or less acknowledging that they have the same problem. You use components, but don't know where it is. So if you don't know it's gone bad, or even if you know it's gone bad and you don't know where to find it, you can be in big trouble. In development, as we've gone from waterfall native, releasing once a year, sometimes even less frequently than that. Typical waterfall process is a big long requirements phase, a big long development phase. Way down the line, just before deployment, you handed it to security, who's going to go in and try to analyze it and find out if there's any problems in it. As we moved into Agile and now into DevOps, that's all about speed. We need to get releases out faster. If we're looking to deploy every 2 weeks instead of every 2 years, we've got to have the ability to speed up that development. The vulnerabilities, the use of open source helps enable us to speed up that development, but the vulnerabilities we could be introducing introduce the risk. The application is the new security perimeter. That quote is from someone very high in Office of Secretary of Defense, but that's typical across all of the government agencies that we're developing software for. Over the past few years, something on the order of 95% of the cybersecurity spending has gone into network and endpoint type security. About 84% of the known breaches have been at the application layer. So we're protecting the networks, but because of the vulnerabilities in applications, that's how people are getting in and doing exploits. Back to Mr. Deming. One of the things as we move to those higher speed things, improving the process includes better allocation of the human effort. And what that means is automation. The old waterfall approach were typically manual reviews at the end of the process. To handle the volume that we're supporting with much more rapid development, we're looking at the need to automate what you're doing out there. So the idea of being able to automate the decision, we call it a DevOps native platform. We apply it, we like to say, early, everywhere, and at scale. So what does it mean? Applying it early. Shift all the way left. Don't wait till the end of the process to look for security vulnerabilities. Vet new components right at the front door before you bring them in from the outside world. Quarantine and block bad stuff from coming into your internal supply chain. And then avoid rework to keep the costs down. If you can do things wisely right from the beginning, that you don't get it back later, about 30% of a lot of development efforts is fixing those problems that were found later. So being able to avoid that work up front by shifting left, Gartner agrees with that. I can get you the name of the actual white paper, but they had a statement in there about the fact that one of the major problems is that developers are unknowingly downloading vulnerable components, and they recommend the use of a firewall to block open source components that are bad. And in fact, they referenced us by name, which was great. We say do it everywhere. Automate the governance across the SDLC. Give the right tools to every step of the way. Developers, build engineers, deployment engineers, as well as the security assessors at the end of the process, so that you can find things early, so you're reducing the mean time to detection. If you find it early enough, mean time to repair is also much more quick, and then getting rid of the manual reviews at the end of the process. And then at scale, the volume of releases, the sheer numbers of open source components that people are bringing into their development activities today, you need to be able to automate the decision processes on what's good, what's bad, and what to do about it. If I have downloaded something that's bad that we've not been using before, I can automatically block it at the front door. If I'm using it in development, my automation may say, let the developer still build it, but throw him a warning that lets him know he's got a problem. That way you don't break the build, let him try things out. But if he doesn't resolve it and tries to release to test or deploy to production, you can have the automation fail that build. The ability to be able to automate these things is highly dependent on accurate data about those open source components. And Curtis will touch on that a bit later. But the precision of identifying and knowing what you have enables you to then make that automated decision. Are folks familiar with our risk management framework? I see a lot of nodding. Most of the applications that we develop for the federal government today will need to go through some sort of RMF process. It varies extremely from one agency to the next on how rigidly they're enforcing it, but by law they all have to, and eventually the ones that are not so much yet will catch up. So that what they're doing, going through and categorizing the information system, selecting appropriate controls for that category, implementing the controls, assessing to be sure that they were followed, and then authorizing the system to be used. And once it's been authorized and released into production, keep on monitoring it because things go bad over time. Sonatype helps with that automation in, wrong button, sorry, in 3 specific controls defined by the RMF. The first is vulnerability scanning. Scan your applications to identify any vulnerabilities that are in them. We see many, many organizations doing a source code scan and checking the box that they've done vulnerability scanning. What people don't realize is that most of those tools only look at your human readable source code, and they can't see the binary components that you've downloaded from third parties that are embedded in there, which is what Sonatype is doing for you. So they're checking the box, but they've got a big blind spot because remember we said 10 to 20% of the application is source code, custom source. That's all their tool is looking at. So they've checked the box that they've done vulnerability scanning when they didn't look at 80% of their application. Check that every step of the way across the life cycle. So don't wait till the very end in a reactive method and then send it back for rework. Identify it right up front in each step of the way. So the early and everywhere messaging. Shift left, give the same precise vulnerability data to everyone. Another common problem we see is different vulnerability tools. So one comes in with a list of things, another one that's prone to false positives comes in with a completely different list of things. For the security assessor, who's now got a different list of problems than development had, and they run into a lot of battles over deciding what's real and what needs to be fixed. The next control required by RMF is having a bill of material for your application. When we scan your application, we generate a complete bill of material of all of the open source and third-party components out there. And if you want to defend against attacks, the first thing you need to know is what is it that you need to defend? What are you using and where is it? So this is another automatically generated, and then once you have that information, you can see each component that you have, licensing issues, security vulnerabilities, age, lots of things about that component to help you get a good big picture view of what's happening in your application. And once you have that bill of material, you can now continuously monitor that. So you don't need to go in and rescan things on your production server. You've generated a report that says here's everything in it. So you can recheck that list on a daily basis or even more frequently if you choose to identify if something new happens. A lot of people, things they do to find vulnerabilities being exploited and things like that are looking at logs and performance monitoring, and they figure out that there's a security problem when there's a huge spike in activity when somebody starts hitting and exploiting a vulnerability. We notify you as soon as that vulnerability's been identified. So instead of reacting, we can proactively say, oh, there's a new problem. And just what we talked about with struts too, people sending armies of people out to find where they used it. We have a dashboard that says, click on the component view, look up the component, and oh, I've used it in three different applications. I can click on that and drill down and know exactly what 3 applications they are. And these 2 are in production and that one hasn't reached prod yet, so those 2 are my first priority to get out there and resolve. So all of these things help you, the whole DevSecOps idea, get these controls in, but with automation, what we call DevOps native. I was at a DevSecOps panel discussion a few weeks ago, and there was a vendor for what we call a waterfall native tool who was one of the panelists, and he said, I don't believe in shifting left because it makes life for developers too hard. And I was ready to jump up and challenge him, but one of the other panelists, who was a DevSecOps person from a major bank, and happened to be a customer of ours, but she didn't mention our name, but she immediately told him, if shifting left makes it too hard for the developers, you're not giving the developers the right tools. So that's where we talk about the DevOps native. Don't just take the tool that was used for a manual scan at the end of the process and dump that on the developer. We give you tools that are appropriate for each context. If you're a build engineer, something that plugs right into your Bamboo or Jenkins. If you're a developer, plug into your IDE so that you've got the right tools and you're able to choose wisely up front and it doesn't get thrown back in your face later for rework. A little bit about how we work with Red Hat, since it's a Red Hat conference. Curtis will walk you through some of that.
We do the passing of the mic ceremony. Thanks. So Mike, we'll get into the Red Hat solution, but also, so Mike sort of pointed out, the state of the supply chain report sort of tells us a problem exists. That's the empirical data that says a problem exists. We're also going to get a little bit into sort of how that problem came to be and get a little deeper into how we solve it, more so than just saying automate, right? this is one of my favorite drawings. Our data science team did this drawing a couple years ago. This is a data visualization of the dependency map within Maven Central. So this is looking at every component, and this is back when there was only 30 billion downloads, and looking at their relationships and then using a visualization tool. And what you should take away from this is it's impossibly complex, right? This is a kind of story that we talked about earlier this morning in the main room, right? The complexity is really what is the tipping point for most of our problems that we have today. So when we think about how, why teams struggle to deal with this problem, it's for reasons like this. If I submit a ticket to my security professional to help me and say, I want to use struts, he has to be smart enough to know that struts maybe uses 20 other things. And the truth of the matter is he's not smart enough to do that. He doesn't have that information. That information doesn't flow to him. That flows to the developers. He has the security information, which isn't going to the developer, and we'll touch on that in a little bit. As a company that's looked at this problem very closely for about 10 years, here's some things that we've learned. So we look at those suppliers, right? We grade and judge those suppliers in that state of the supply chain report. A brand new one will be out in a week or two. I wish I could share a URL with you now, but please be on the lookout for it. When we looked across, the median MTTR, one of the great DevOps stats, right? Mean time to remediation, was over 300 days. That's the median. We didn't use the average because the average was a whole bunch higher because there's a couple of things out there that still haven't been fixed for over 3,000 days. They're never going to get fixed. Their number is always going to go up, and they're going to just keep dragging the average up. If we narrowed it down, though, and looked at those components that just had the worst of the worst defects, CVE of 10, right, so the highest rating, they tend to get fixed in about 200 days. Now that's, early in my career, that would have been acceptable because that would have been within our project cycle of 6-month releases. I probably could have almost dealt with that. In this day and age, this number is abhorrent, right? Struts, in their defense, is much better than the average. They tend to fix their stuff in about 100 days. Also understand that a big part of this problem is not so much that these suppliers are not fixing their problems, it's that they too are unaware that they have downstream dependencies that have a problem that they're dragging in with them. So Apache might be releasing something that's perfectly fine, but they're pulling in some other component that has the problem. They have no awareness of them. That supplier has no awareness, so nobody's fixing it. Right? So you start to understand the nature of the problem a little bit. So there was a cohort, I won't name them, there's a handful of projects that were really, really good. These were some of the best, 30 days MTTR. Still not quite within my 2-week sprint, right? Still not quite in modern development terms. Now, having said this, we noticed, even back then, and it's the reason I, in my channel and alliance role, put a lot of time and energy into working with Red Hat, because Red Hat is a world-class supplier. Red Hat JPOS repo tends to fix all their issues within 2 days. Many of those issues get fixed in negative days. If you're familiar, there's an embargo period. So a lot of their stuff gets fixed before they even sort of announce what the defect was. So, and at Red Hat Summit, which I attended and got to be in some talks there, they announced that they will patch RHEL within a day. So that's what makes Red Hat really important in this equation, is because they are a world-class supplier providing a foundation on which you need now to deliver a secure application on top of. Right? So we're really excited about working with Red Hat because they embody what we are passionate about. So I won't go over all these, but I will say that in these 10 years of looking at this, is the problem domain. So the software supply chain report is the empirical evidence that a problem exists. I've explained the complexity, I've explained some of the issues around dependencies that led to this. But in terms of you guys solving this for your apps, the problems are that information gap I alluded to before. Security information goes to a security guy. He's doing a late cycle scan and then throwing it back at the developers. That's a workflow nobody likes. And you can replace that security with any other word that's similar, and you've got a similar bad dynamic. Not only that, the security guys themselves didn't really have the information they needed because security information does not map to the component level. If you're familiar with the NVD, National Vulnerability Database, it often tends to talk about platforms, right? So a CVE maps against a CPE. So my classic example is there's a vulnerability out there that's known to exist in Xerces that exists in the IBM JRE. So when you look that up, it talks about the IBM JRE. It never mentions the word Xerces. Now, if you're using Xerxes in your project, there is no way to make that connection. Your security professional, your developers, nobody can make that connection unless you dig in, right? The other thing is the precision. The precision matters on both ends. One is, do we have that precision to map to the component? The other one is, how do I know the provenance of the thing that I'm using? So there's all these free Lego blocks on the internet. How do I know my developer is using the one that was provided? How do I know it's not a different one or it's been modified or altered? Right? So there's those kinds of things in your mind too, so you have to think about. Contextual. Early on in our product, when our customers said, hey, we want to govern components, they told us what they needed. They needed whitelisting, right, and blacklisting. So we implemented a feature called procurement in Nexus. It gave them exactly that functionality. And then we continued to partner with our customers to see how that worked, and it didn't take us very long to figure out it wasn't working very well at all. And the reason for that is it lacked any contextuality. Blacklisting a component for use anywhere only works if it's a particularly abhorrent component. But there's a lot of components that you can use in some cases, but not others. It depends on the app. Mostly this gets into legal stuff more so than security, right? So now you're getting into licensing issues. It also sort of depends where in the life cycle or what team is it? Is it an R&D team or is this a customer-facing app team? Two very different use cases. I don't want to apply the same policies to like a blanket. I need policies that are flexible with which teams I'm working with, what app it is, what's the use case, and where in the life cycle are we, right? So we needed those kinds of things to do. The other thing, and this should be obvious to anyone at this point, is almost all the stuff we talked about up to now, like the MVD and stuff, tells you have a problem. Thank you. Well, now what? Now what do I do? Well, now what am I supposed to do? Right? Google it. What, where do I go from there? So the other piece of the missing information is, I have a problem. What can I do about it? Right? And then, of course, all that data has to be continuously updated. And when you put all these things together, and this is where it gets interesting, now you're capable of automating, right? So we talk about automating, but to even be capable of automating, you have to have solved this problem domain so that I'm precisely identifying things. I have really good, accurate data. And now my automation has the ability to know with high confidence the thing I'm looking at is the thing I'm aware of. This data is what goes with it, and now I have a policy that tells me whether or not it's okay for this app at this point in the life cycle, right? And automation only works if you can turn your back on it, right? Automation isn't automation if you got to stare at it. If you got to constantly check the results, that's not automation. Automation is fire and forget. Now, I've set up a lot of automation in my days. You stare at it for a while, and then once it earns your trust, then you turn your back. So, what does that mean in terms? I like to use the container because I feel like people can get their head around the idea of a container because we think of it as being relatively small. But this doesn't matter. This could be a container. This could be a VM. This could be bare metal. It doesn't. The story is the same. We just take the little container box off. Everything we have is an operating system. You're going to layer some runtime on top of that, and you're going to put your app on top of that, right? It doesn't almost matter what language you're using, right? It's all the same stuff. You're putting an app. The app runs on something that can talk to the operating system. The operating system can talk to the hardware. So that's the full stack. And when in context with Red Hat, if you were in this room 2 sessions ago, and I think some of you were, they have the OpenSCAP, which does a really good job of identifying not CVEs. OpenSCAP is much more about configuration, right? To be really security compliant at the operating system level, it's much more about permissions and file settings and configuration items, or the absence of things, or the presence of cryptography, right? So it's much more complex than do you have a bad component. It is capable of reporting on CVEs against components because that would, of course, be a problem against a security profile. And then what we did together at Summit and recently in New York was showcased how together with OpenSCAP in a, it could be an OpenShift context or not, we can secure all 3 layers and help you put a world-class app on top of a world-class platform that Red Hat provides. So just a little bit more specifically how that's done. We've been talking about this earlier today, and I've heard a few references to this. I don't know, both Neil Ford talked to, anyone listen to Neil Ford's talk earlier? So Neil Ford, what are you talking about? You're testing for fitness, right? Like you have all these capabilities, and you need a way in your delivery pipeline to know that it meets that criteria, and if it doesn't, it can't get through the pipeline, right? So it's that concept. Also, I also, the J. Paul Reed talk, he talked about active defenses. I think what we're describing here fits both those descriptions, and I like the way they've given me some new perspectives on how to think about it. This is what a software factory looks like, right? Source code control, you're probably using Git. Build systems, probably Jenkins, maybe not, but 80% chance. We provide binary repository management, just a place to store and manage all these binaries, right? It's not super exciting or sexy on its own. And then you have some kind of release process, right? And that represents what I like to call the software factory. And we talked about, I've heard it out there too. Things are assembled today. There's a manufacturing process. So really what we're saying is, wouldn't it be great if you had a firewall that, as a component, is entering your system? It could be immediately inspected for fitness, for purpose, and blocked if it was bad. Boom, done. Like immediate feedback to the developer. You can't have this. Yeah, anyone get an email that says, this email used to have an attachment, but you didn't get it, kind of thing, right? It's just like that. It's like saying your email, the attachment was taken away because it was deemed dangerous, right? So it failed to scan. And the big difference, though, there is no good answer to the data problem. The data doesn't exist, right? You can subscribe to every data feed out there. You're not going to get what you need. So we built a data team that subscribes to every data feed out there and then curates it, right? We do the extra work to make sure it maps to a component. We're verifying against source code. The other issue is like half the problems go unreported. A huge number of vulnerability issues are not even reported to NIST. Where you find them? GitHub commit logs, right? You find them on websites. You find people that are publishing and talking about this stuff. So we scrape and do a big data exercise on all of that stuff, and then we have a security team, security experts that review that information and put together data that is intelligible by all the stakeholders. Your security guy can understand it, and more importantly, your developer can understand it. Because if the developer can see the list of what he's working with and get a flag and whether or not it's okay to use, if it's fit for purpose for this application, they can now do the right thing the first time, right? So that gets back to Mike's point. If we give them the right tools and make it easy to get rid of the bad things, only produce a build with good things, and then start it down that pipeline, we've got a chance. Now, I've supported developers my whole career. I don't trust them. You can't ever get them all to do what you need to do. So you bake yourself into the build, because that's my choke point. Everything has to go through the build. Now, even if all my developers don't necessarily pay attention, I have an opportunity to break the build, but I don't think breaking the build is the right thing to do. It slows things down too much. What we do is we provide feedback. We can warn. We can make it marked unstable if you're familiar with Jenkins. And then just make sure now it's not just the developers. Now you got a bigger delivery team that has awareness of this issue. Ideally, that's what they need to get it fixed. But should they try to release it into the release process anyway, another layer of automation there that could say, no, I'm done. This thing is just stopping, right? It cannot go any further. I've given you information, I've given you feedback, and you've persisted anyway. I'm pulling the cord, assembly line breaks. But let's say you do a great job, right? And it's actually not that hard. This is one of these problems that feels like it's a really big swamp to drain. But in my experience, our customers can drive this risk down significantly in a short amount of time. But you're still up against a saying that we like to say, code ages like milk and not like wine. It does not get better with time. And containers are worse. Containers are mere like fish in the fridge. You got a couple days. Because now you got all the layers. One of them's bound to go sour on you. But so anyway, so continuous monitoring. Again, what we can do is keep that bill of materials and basically 3-4 times a day, we're looking for any updated intelligence feeds. If it maps to anything you're using, now alerts are going off. And you're now in a position to appropriately alert production and security folks here. Here's just feedback to the developers. Somewhere in here, maybe it's like the release management team, right? So because we have all this context, we can make sure we're getting the right information to the right people at the right time. And it doesn't become one of these systems that's super noisy, right? It's not spamming everybody all the time, just the right people at the right time. So hopefully we've sort of, the problem is there's a lot of bad components out there. I know the percentages look bad. The percentages don't look scary, right? 5-6%. But when you consider that the average app has hundreds of components, it's literally 80 or 90% of the apps actually have a problem. So when you look at wow, we downloaded 250,000, but there's only like 17,000 bad ones, that doesn't seem so bad. But the truth, we scan a lot of apps. Virtually every app has a problem. It's rare that we find an app that doesn't have one. And when you get it out clean, there's a way to, sort of now be in front of this. And as Mike pointed out, you're in a position to be proactive. If you get notified of that 0 day, on 0 day, you're now planning your remediation. You're probably even waiting for the fix. But at least you have awareness. And as a risk team, half the battle is just being aware, right? Being able to report that awareness is really all anyone's asking you to do. And that's how you it's not like you can never have any risk. You have to manage the risk you have, and to do that, you have to be aware of it.
And know where it is.
And know where it is. All right, I think we've gone a few minutes over. Thank you very much for your time. Well, I'll be around if there's any questions, or you step up now. Thanks.